In this video, we'll walk through an example of the second quiz, which is evaluation. In this case, we're going to value Campbell's Soups, both their bonds and their stocks. We'll start with the bonds. For the bonds, we see that the coupon is 6%. So that's important. 6% is going to tell us how much the cash flow is every 6 months. Remember, corporate bonds pay interest every 6 months, and then they pay the entire principal back at maturity. This bond was issued to be a 15-year bond, but it was issued 13 years ago, so that makes it essentially a 2-year bond. All you care about is the time to maturity. So when we value this bond, what we will do is value it as a 2-year bond. So we need one column that says time. We need another column that gives us our cash flow. We need the discount factor. And then we need the discounted cash flow. Time is, since it's really 2 years left on this bond, we want the time to be 2 years, but we get cash flows every 6 months, so we'll actually get a cash flow in 6 months, which is the time of 0.5. We'll get cash flows in 1 year, which is 1, cash flows in 18 months, or 1.5, and cash in 2 years. The cash flow, because the bond pays a 6% dividend, then the cash flow is going to equal the face amount, which we just assume is $1,000, times the coupon, which in this case is 6%, divided by 2, because we get that 6% but over every 6 months, so we get half of that 6% twice a year. So our cash flow is going to be $30. So there's our cash flows, $30, $30. Let's put a dollar sign just so we're really clear. $30, and then at maturity we will get our $1,000 back plus one more $30. So those are our cash flows. So this is the truth for every single bond, every corporate bond. The coupon divided by 2, so 6% divided by 2, or $30, is your cash flow until the very, very last time period, and then you get your $30 plus the $1,000 back. Our discount factor will be 1 divided by 1 plus the rate raised to the time. So in this case, the rate, as you can see up here, the rate is 3%. We need to adjust that because we need to use the effective yield. The effective yield equals 1 plus the discount rate, the 3%. In this case, we divide by 2 because we get 2 payments a year. If we got 12 payments a year, we'll be dividing by 12. We raise that to the second power because it's twice a year. If it had been monthly, we would have done it to the 12th power. But here, it's for all corporate bonds, you just assume twice a year. That's the standard. That's going to give you 0.0302 as our discount rate. So in this case, our rate is 0.0302 and our time is 0.5. That equals 0.9852. The next time we do 1 divided by 1 plus 0.0302 raised to the first, and that equals 0.9707. The next one, we take 1 divided by 1 plus 0.0302 raised to the 1.5. I don't have enough parentheses here, so let me fix that. make sure you add the 1 plus 0.0302, then raise that to the power, and then divide that into 1. You might want to practice that to make sure you're getting exactly the right number. And then the last one is 1 divided by 1 plus 0.0302, and this time raised to the second power. And that equals on the previous one, sorry, that one equals 0.9564, and then the last one is 0.9422. So when you multiply that across, $30 times 0.9852, and that equals 29.56. The next one gives you 29.12. The next one gives you 28.69, and then the last one gives you 970.47. And you add all those together, and you end up at 29.56 plus 29.12 plus 28.69 plus 970.47. That gives you the price of the bond, 1057.84. You notice that it's greater than $1,000, and that makes sense because if the coupon is greater than the discount rate, that is, you're getting paid 6% in a market where everybody else is getting 3%, that bond will be worth more than the face of the bond. It's what we call a premium bond. So there's how we do the bond. For the stock, we have two models we need to use. The first one is the dividend discount model, which the value of the stock is the dividend times 1 divided by the discount rate, KE, minus the growth rate. In this case, dividend 1 equals dividend 0 times 1 plus the growth rate, because we don't have dividend times 1, we have dividend times 0, which is the dividend from the last 12 months. That's $1.40, so dividend times 1 is going to equal $1.40 times 1 plus our growth rate. So our dividend, if you go back to the assumptions, our dividend is $1.40. Our growth for long term is 4%. So we increase that by 4%. And that will give us how much our dividend is expected to be next year, which is, I'm going to not round it here, 1.456. Better not to round that because it can get pretty material to your calculation. 1.456 divided by, and in this case you got the discount rate. In the problem, the stock discount rate is 7.2%, so we'll discount it by 0.072 minus 0.04. When we do all of that, we get a value of 45.50. So that's a dividend discount model. And then the H model is this formula right up here. The hint formula is the H model. You notice it's exactly the same as the previous model. Dividend 0 times 1 plus the growth rate. That's what we did to get dividend 1. So dividend 0 times 1 plus the growth rate. We're going to add to that dividend 1, which is $1.40. So if you look back at the formula, dividend 0. So we did dividend 0 times 1 plus the growth rate. The growth rate is the 4%. Dividend 0 times H. Well, what is H? Well, we look down here and say Campbell has seen some great growth in emerging countries. So its short-term growth is 9%, and we expect that to last for a 6-year period. So what that means is that our H is 6 years, and we divide by 2, because think of the H as the half-life. So our H is half of that unusual growth period. The unusual growth period, we're told right here that it's 6 years. So our H is 3. So we're going to take $1.40 times 3, which is our H. If you look back at the formula, $1.40 times H, and we're going to multiply that by the difference between the short-term growth rate and a long-term growth rate. Short-term growth rate was given at 9%. Long-term is 4%, so we'll multiply that by, and make sure you get your parentheses correctly, 0.09 minus 0.04. That whole thing is divided by the exact same thing you divided by in the other one, the 7.2 and the 4%. So your numerator looks exactly the same. It's going to be your discount rate minus your long-term growth rate. So in this case, 0.072 minus 0.04. And when you do all of that, you get an H model valuation of 52.06. You can actually check the H model, because the H model should get you the dividend discount model value, 45.50, plus 1.40 times 3 times 0.09 minus 0.04 divided by 0.072 minus 0.04, and you'll notice right here that's that whole section we added to the H model. So it should be the dividend discount model value 45.50 plus what we just added here, and when you do that you should get 52.06 if you want to double check the work. So your answer here is the bonds value is 1057.84. The dividend discount model value is 45.50, and the H model value is 52.06. You don't have to check your work, but if you want to, you can just double check and make sure your H model simply added this extra piece. All right, thanks.